China has just dropped a major bombshell on the global high-tech supply chain. Starting December 1st, any lithography-related goods that contain 0.1% or more China-origin rare earth materials, no matter where they are ultimately produced or how they are transported, must apply for an export license from China. At the same time, China has also launched a stricter case-by-case approval system. Any exports involving equipment for 14 nanometers and more advanced logic chips, high-end memory chip production equipment, and their key materials will enter an individual review process. Once this policy was announced, the entire global semiconductor supply chain instantly felt the shock. But the general belief is that this is China's precise countermeasure against the Netherlands, because the policy will almost cut off the central lifeline of the Dutch lithography industry. But the question is, why has China suddenly targeted the Netherlands? And when the Netherlands loses the support of China's rare earth supply chain, what kind of real-world impact will it face? In previous videos, we mentioned that on September 30th this year, the Netherlands suddenly imposed a confiscation-style forced takeover on a Chinese semiconductor company. Without any prior communication, they launched regulatory measures against a company called Nexperia. Even more unexpected, the Amsterdam Court of Appeal removed Nexperia's Chinese CEO, Zhang Shuijing, from his position without a hearing, appointed a foreign executive as interim CEO, and transferred 99% of the company's shares to a third-party trust. The Dutch authorities claimed that the company had serious management deficiencies, and their intervention was to prevent supply disruption and protect the economic security of the Netherlands and Europe. But the absurd part is that the Netherlands has provided no substantive evidence to show that Nexperia poses any threat to Europe's economic security. In fact, Nexperia was fully acquired by China's Winji Tech Technology in 2019 for $3.6 billion. After years of development, the company now holds a highly important position in the global automotive-grade power semiconductor sector. Its products are widely used in electric vehicles, industrial control, and other core applications, and its customers include major international giants such as Bosch, BYD, and Siemens. And clearly, the sudden move by the Netherlands to sanction this Chinese semiconductor company is very likely an effort to follow the United States in its campaign to suppress China's technological advancement. Because starting from December 2024, the United States placed Winji Tech Technology on the entity list without any factual basis, attempting once again to crack down on China's semiconductor industry. And in September 2025, just one day before the Netherlands forcibly took over Nexperia, the U.S. Department of Commerce issued a so-called piercing rule, expanding sanctions to include all subsidiaries in which companies on the entity list hold more than 50% ownership. As a result, Nexperia's lifeline was immediately cut off, unable to purchase key equipment and technologies. Perhaps the Netherlands initially believed that with support from the United States, they could offend China slightly and then smoothly take over this high-quality semiconductor company. But now, it seems the Netherlands has realized they made a mistake with a very high cost. What exactly happened? 1 week after the Netherlands announced its takeover of Nexperia, authorities in Beijing issued a new export control notice. The regulation explicitly prohibited Nexperia's China facilities and their subcontractors from exporting core products, such as automotive power semiconductors. Public information shows that Nexperia has a packaging and testing plant in Guangdong covering about 80,000 square meters, mainly producing discrete devices, analog and logic chips, and power devices. After China implemented this policy, the capacity utilization of Nexperia's China facilities immediately dropped from 90% to less than 10%, and its delivery capability to European customers plunged from 95% down to only 3%. The reason China's counterstrike has been so effective is that although Nexperia's headquarters is registered in the Netherlands, more than 70% of its core production capacity is located in Dongguan and Shanghai in China. So while the Dutch government appears to hold the company's equity and intellectual property, the real ability to manufacture and supply products remains entirely in the hands of Nexperia's factories in China. What the Netherlands took over is closer to an empty shell of a company that has had its soul removed. And not long after the takeover announcement, Nexperia's China entity clearly informed all employees that they would only follow instructions from the company's legal representative in China. This effectively drew a complete operational boundary with the Dutch side, making the takeover plan almost impossible to execute in practice. This means that the Netherlands has failed almost completely in its takeover attempt. What the Netherlands did not expect was that China's countermeasures would trigger even greater chain reactions. According to what I know, after China halted exports of core automotive power semiconductors, the pressure on Europe's automotive industry erupted almost immediately. For example, in Germany, Volkswagen's main plant in Wolfsburg was forced to shut down all production lines, with direct economic losses exceeding 100 million euros per day. BMW's Munich plant also saw the delivery cycle for its high-end models extend from the previous 3 months to 6 months, with order losses reaching a historic high. In just 2 weeks, European automakers saw more than 3.5 billion euros in output erased, and over 12,000 workers faced temporary layoffs and income reduction. ACA, which represents Europe's top automakers, issued an urgent and rare statement, warning that if chip supply cannot be restored, Europe's automotive industry will suffer irreversible damage. Europe is so vulnerable because Nexperia's position in automotive-grade power devices is simply too critical. It exports more than 110 billion chips a year worldwide, and from brake control to lighting systems to high-voltage power modules, almost every safety-related automotive function relies on its components. From Volkswagen and Toyota to Tesla, virtually all major automakers depend on Nexperia's supply. Of course, the impact is not limited to Europe. Automotive industries in North America and Brazil have also experienced ripple effects. Honda has already announced production cuts and shutdowns at multiple assembly plants in North America, including one in Ontario, Canada, that has been forced to cut capacity by half. Data shows that 86% of Europe's key industrial companies purchase related chips from Nexperia's China facilities, and about 1/3 of automotive supply chain companies rely on Nexperia as an exclusive supplier. Switching suppliers now is practically impossible, and new product automotive-grade certification cycles usually take months or even longer. By November 5th, the German Association of the Automotive Industry had issued a final ultimatum to the Netherlands. It warned that if the Dutch government cannot provide an effective solution, Germany, France, and Italy will invoke the crisis exemption mechanism under Article 17 of the EU Chips Act, placing Nexperia's European wafer fabs into projects of common European interest, thereby bypassing Dutch legal control. This appears to be a direct warning to the Netherlands that if they do not stop suppressing Nexperia, they will soon push the core chip supply chain of Europe's automotive industry into the abyss. But now, China has begun its second countermeasure against the Netherlands, and this time it directly targets the most critical sector of the Dutch semiconductor industry: lithography machines. What exactly is happening? On December 1st, 2025, China's rare earth export control measures officially took effect. The industry widely believes this is a strong counterattack by China against the Netherlands for the forced takeover of Nexperia. Based on available information, this new regulation includes 2 clauses with extremely powerful impact. The first is the so-called 0.1% red line restriction, which clearly states that as long as lithography machines or related equipment contain 0.1% or more China-origin rare earth materials, no matter which country or brand the product comes from or how it is transported, an export license from China is required. along with reporting of end-user details. This effectively closes off any possibility of third-party transshipment to bypass regulations. The second clause directly targets advanced semiconductor manufacturing. Any supply involving mass production equipment for 14 nanometers and below logic chips, equipment for 256-layer and above memory processes, and testing equipment and key materials must undergo a case-by-case approval process. This means China has accurately seized the most critical choke point of the Dutch semiconductor supply chain and imposed a substantive constraint on its technological advantage. The reason rare earth controls have such a major impact on the Netherlands is that global rare earth refining capacity is extremely concentrated in China, which controls about 90% of worldwide refining output. And the Dutch national champion ASML is deeply dependent on China's rare earth materials in lithography machine production. The ultra-precise lens polishing for EUV machines relies entirely on high-purity cerium-based materials from China. The internal motors use more than 10 kilograms of rare earth permanent magnets, accounting for more than 30% of component cost. The magnetic levitation system requires heavy rare earth elements such as dysprosium and terbium, and there is currently no truly viable alternative global supply for these critical materials. Data indicates that the rare earth compounds ASML imports from China each year account for 26.4% of China's total rare earth exports, forming the essential basis for its equipment precision. In the past few years, ASML has repeatedly attempted to push its supply chain to reduce reliance on China, but has never succeeded. When they tried replacing key rare earth magnets with ordinary materials, overall production costs for lithography machines increased by about 40%, while performance dropped by around 30%, making it impossible to meet advanced process requirements. Meanwhile, Southeast Asia's rare earth refining capacity accounts for less than 5% of the global total and is significantly behind in purification capabilities. Although the United States has rare earth mines, extraction and refining costs are roughly 3 times higher than in China, and the purity typically reaches only about 92.9%, while below the 99.9% required for lithography equipment. Under simultaneous pressure from supply chain cost, technical difficulty, and quality control, ASML has virtually no feasible pathway to eliminate its dependence on China. Even more urgent, ASML's current inventory of rare earth materials can only support about 8 weeks of production. If export license approvals are delayed, its monthly output may decline by 15 to 20 machines, and annual revenue losses are estimated to exceed 3 billion euros. The resulting order delays and market share losses would further expose the company to significant cascading risks. At a fundamental level, the Netherlands has imposed restrictions on China in terms of technology and equipment, yet remains heavily dependent on Chinese supplies of key materials and production capacity. This imbalance of interests will inevitably cause the Netherlands to suffer greater losses in the long run.